In this review problem, we'll take a look at the Laplace transform of these integrals. First off, f of t is equal to integral from 0 to t e to the minus u cosine 3u. Let's write this in the form f of t is equal to integral from 0 to t of f1 of u times f2 of t minus u du, where the function f1 is the original integrand e to the minus u times cosine of 3u, and the function f2 is just simply the constant 1. So this integral that we see here can be thought of the convolution of this function and the function 1. So therefore, the Laplace transform of f is equal to the Laplace transform of f1 times the Laplace transform of f2, because f is the convolution of f1 and f2. Okay, now using the table, the Laplace transform of this function, e to the minus u cosine 3u, is going to be s plus 1 minus negative 1 over s plus 1 squared plus 3 squared. And then the convolution of the function 1 is simply 1 over s. And so that leads to the Laplace transform s plus 1 over s times s squared plus 2s plus 1 plus 9, which is plus 10. And so that is the Laplace transform for number 1. Okay, number 2. This is a convolution, written more simply. So we have, let's write it like this. The Laplace transform of g equals, well, this is g of t is equal to the integral from 0 to t of, let's say, g1 of t times g1 of u times g2 of t minus u du, where g1 of u is sine u and g2 of u is cosine u. And so therefore, the Laplace transform of g is going to, since g is the convolution of these two functions, Laplace transform of g is going to be the product of the two Laplace transforms. Okay, the Laplace transform of sine is 1 over s squared plus 1. The Laplace transform of cosine of u is s over s squared plus 1. And so this is s over s squared plus 1 quantity squared. And that is the convolution of this integral. Or sorry, the Laplace transform of this convolution integral. All right, lastly, h. Find the Laplace transform of this. Now this actually has two parts. For the first part, let's figure out the Laplace transform of integral from 0 to t, u to the third e to the minus u du. Okay, that's the first thing we're going to figure out. Now again, this is going to be the Laplace transform of two functions, where h1 of u is equal to u to the third e to the minus u, and h2 of u equals 1, just like earlier in this video. And so this will be equal to the Laplace transform of h1 times the Laplace transform of h2, because this integral is the convolution of these two functions. Okay, now the Laplace transform of this function is going to be 6, 3 factorial, over s minus negative 1 to the fourth. The Laplace transform of 1 is s, so, well, 1 over s, and so we get 6 over s times s plus 1 to the fourth. Now what do we do when we have the same thing multiplied by t? Well, just to recall, we have a rule that says this. If I take the Laplace transform of negative t times f of t, the result is the derivative of the Laplace transform. And so in this case, I don't have the minus sign, so it'll be negative the derivative of the Laplace transform. So the practical upshot is that the Laplace transform of t times this integral, 0 to t, u to the third e to the minus u du, that'll be equal to negative the derivative of the thing we just got here, 6 over s plus 1 to the fourth. And now we just have to find the derivative of this. So to do this, it's going to be, okay, we have this raised this raised to -1, so it's going to be 6 over s squared, s plus 1 to the eighth on the bottom, times the derivative of the bottom, which is going to be s plus 1 to the fourth, plus s times 4 times s plus 1 to the third, times the derivative inside, which is 1. Then I can factor out an s plus 1 cubed, and that'll knock out s plus 1 to the some of the terms down here. So I'll get s squared, s plus 1 to the fifth, 6 is still in front. I have an s plus 1 that survives off this part. Also, I have 4s that survives off this part. And so the practical upshot is that this is equal to 6 times 5s plus 1 over s squared times s plus 1 to the fifth power. And so the logic for this one is that this integral can be thought of as a convolution of two functions, and so I can get the Laplace transform of this pretty quickly without doing the integral. And then if I have the Laplace transform of this thing times t, that's equal to negative the derivative of the Laplace transform.